Offshore कैसा आएगा? Because sometime what will happen? So sometime what happens is, let's say the belts are shifting more towards the north. Let's say now the STHP is over 40. Okay? So from 40, the winds will go where? They will go towards the equatorial low pressure belt. Now this region which is below 40, that is 30 to 40, it is coming under what? Trade winds. Do you agree? Yes or no? Yes. Now see here. This is Europe, and let's say here it is the belt. Now this is STHP, right? This is somewhat I am talking about, let's say 30 to 40. So sometime it will be under directly STHP. Sometimes belt can also shift up to 45. Yes or no? Yes. And in that case, what will happen? See here, this is the African part that is exactly near the Mediterranean. When the belt shifts north further, let's say, or here it is STHP. So the winds which are coming here, let's say this Mediterranean region, what is this area? It is under this one. That is under which one? The offshore trade winds. Yes or no? Yes. Western part it is. Yes. So sometimes it will be under directly STHP. Sometime it will be under offshore trade winds. Yes. So far we have discussed up to westerlies. We finished up to westerlies, right? Climatic patterns related to westerlies we have discussed. Yes. One is I discussed British type of climate. Second, we have discussed Mediterranean type of climate. Yes or no? Yes. Climatology, again I'm saying you, is very, very important. It is, however, easy. But what happens is sometime if you are missing the information, then it will become very difficult. So, for example, if I say SPLP will become discontinuous or continuous, you have to be very sure with that. Okay? Otherwise, you will attempt the question wrong. So, in the climatology, your concept must be clear. If you have any doubt, you can ask me. Okay? But your concept play a very important role. Now, last one we are left with, it is polar easterlies. Polar easterlies. If I ask you some of the question from the previous class, let me know when the SPLP was continuous, summer or winters in northern hemisphere. In summers, yes. When it was discontinuous, winters. Why? Because of increased contrast in land and ocean. Okay. Tell me, westerlies increase in terms of their speed when they are going towards the pole side. Yes or no? Yes. Why? Yes. Then tell me, westerlies are related to the fronts and the temperate cyclone formation. Yes. Westerlies are also related to the precipitation patterns, especially in the northwestern parts of the continents. Yes or no? Yes. Mediterranean type of climate is produced due to westerlies. Trade winds are always continuous on both ocean and land. They are not continuous all the way, especially over the land. Why? Because of in the summers, local low pressure cells will form. Okay. Trade winds are otherwise known for consistency and regularity, except some areas. Yes. What is the average speed of them? 30, 40, or we can say 30 to 45 kilometer per hour. Why they are known as trade winds? Because they help the merchants ancient time, right? So this is basic things. Now we are coming to the polar easterlies. Now about the polar easterlies, for the prelims you will remember 2-3 things. See here, this is the equator. This is, I am talking about geographical equator, right? Not the pressure belt, that is ITCJ. No, I am talking about this equator, means geographical equator. Now see here, in in case of the sun, when the sun is in which hemisphere? In the northern hemisphere, then what will happen? All the pressure belts will shift towards the north. In that case, what will happen? The pressure belt, which is otherwise here, it will be shifted because of the westerlies are becoming, let's say, they are intruding here. The pressure belt is going northward side, and in that condition, what will happen? You will see the area of the polar easterlies. Sorry, this one, polar easterlies. The area under the polar easterlies will shrink. Yes or no? Yes, the second now. See here, it is in the winters I'm talking about. Northern hemisphere we are considering. Let's say this is winter. What would be the position of the sun? Sun will be in which hemisphere? Sun will be in the southern hemisphere. Let's say sun is here. Now what will happen? All the belts will shift towards down. Yes or no? Yes. Because if it is shifting down, can I say the belt will also shift downward? Yes or no? Yes. All the belts except polar high, they will shift up and down according to the movement of sun. Now, because of this shift, what happens is, can you see here clearly the area under the polar easterlies? Is it expanding? Yes or no? Yes. So one thing that you will remember, the area in which they will blow, it will increase and decrease based on what? Based on the movement of the sun. Number one. That is for your prelims. Okay. So northern hemisphere, they will become, let's say area wise, they will shrink in which month? What is this month? It is in summers. And they will shrink, they will expand in which months? Northern winters. Okay. So number one, this is the point that you will remember. In the winters, in the northern hemisphere, area expands, whereas in the summers, belts shift northward. And area shrinks. These polar easterlies are not known for the speed or the velocity. They are very sluggish type of winds. Why? Because it is the cold air which is heavier and denser. So therefore what happens is it is not known for its speed. Okay. Now see here, one more point that you will remember for the prelims. Now see here, if I ask you when the temperature gradient will be stronger here in between mid latitudes in this area and this area, when the temperature gradient will be stronger in summers or winters? The gradient will be always very strong in winters. Remember that. Okay. Now see here, in the winter, see here, in the winter, they are expanding or shrinking? Just tell me. They are expanding. Now see here, consider this is the area I'm talking about. See here, consider this is the area I'm talking about. I am talking about this is SPLP. And here we have polar high. Right. Now, if I talk about winter, okay, in the winter, what will happen? The coldest would be the air over the polar region. Because of this cold air, what happens is this is going to be the heavier, which is sinking down. Now, when it is sinking down, which is nothing but heavier wind, the denser wind. Therefore, what happens is, see here, tell me, what would be the speed on the surface? Can I say because of this cold air loaded over the head, what will happen to the speed? Will it decrease or it will increase? It will decrease. Why? Because there is a lot of weight of the air and therefore they will become extremely sluggish. In which month? In the winter. The another reason, see here. Now tell me when this SPLP will be continuous. In which month? In which month it will be continuous? SPLP. In summers or winters? In summers or winters? Huh? Winters? बस यहीं पे फंसते हो आप लोग. You have to revise your notes, right? Summer. So in the summers it will become continuous, right? So this is summers, it will become continuous. Why it will become continuous? Again I'm writing here. N number of times I will write so that you can retain. Why it will become discontinuous? Because of what will happen? Thermal contrast between the land and ocean will decrease or increase? Land and ocean, it is going to decrease, right? Now tell me, what will happen in case of winters? I'm using the color for the winters. Now tell me, what will happen in the winters? This will become discontinuous. Yes or no? Yes. Not only discontinuous, tell me when it is going to be stronger. Sir, of course, when it is continuous, it will become very stronger. Yes or no? Yes. Now, in the winters, not only this weight is making them slow, but also there is no incentive to go there. What is the incentive? Why the wind will go from one region to another? Because of from high pressure to low pressure. Now, in the winters, what is the condition here of this SPLP? SPLP itself is not in good shape. Yes or no? Yes. SPLP itself is weaker. And therefore, the pulling factor is not available there. इधर देखो board पे, he will adjust. See here. Don't worry. हो गया? मैं सही दिख रहा हूँ? वही सेट कर रहे थे? Okay. See here now. See here, please. What I'm saying is, see here, why the winds are flowing from polar high to SPLP? Because of the low pressure is attracting them. Now, in these winters, this low pressure itself is weak, and therefore there is no pulling factor. So the one reason is there is no pulling factor. Second is they are heavier, and therefore what happens is their speed will become very, very slow in winters or summers. In winters, even if the gradient is stronger between the latitudes. समझ में आया? So what will happen in the winters? Now you will write down this one as a note. Note, they will become note. Speed of this polar easterlies. Speed of these polar easterlies becomes very slow. In which month? In winters. Because of two reasons. Number one, due to denser cold air Number one, because of the cold air, the weight is making them to become slow. Number one. Number two, SPLP remains weak and non-continuous or discontinuous. So because of these two things, please remember, this is for your prelims, you will remember. That is, the polar easterlies will become somewhat faster in which months? In summers. ये थोड़ी देर पहले ही आपने पूछा था अभी. Yes. If the belt is discontinuous, what will happen? It will become weaker, yes or no? Yes. Yesterday only I explained this one. See here, once again I'm explaining. See here. Do you remember this was the North America, and here I made, this is Europe, here it is Greenland. This is Europe, and see here. I talked about these temperatures here in the Europe. On the land, the temperature was somewhat, I am assuming, let's say minus 50 degrees C. Here also minus 50 degrees C. What area I'm talking about? This is 60, 65. The SPLP is the belt. However, in the water, temperature remains somewhat warmer. So this is warmer. Now, this is cold pressure rather than the low pressure. Okay. Therefore, the belt ceases to exist here because of very minus temperatures, the cold area. This is only over the water, which is slightly warmer. You will have the low pressure area formation. And therefore, what is we are writing? This is the situation of winters. So you have written in the winter, belt has become discontinuous. This is 8th time I am explaining. Okay. 8th time. Again, I am saying this is important. Please careful. This same concept I will use very shortly in the tornadoes. In the tornadoes, see here, the question I will ask, in which season the tornado formation is very common. This is for your prelims. The season is going to be not winters. That is going to be not even summers as well. This is going to be the early summers or the spring. Do you know why? Just I'm telling you here once, the second time when I will explain the tornado. See here, the tornado formation will happen here. And now tell me, this contrast of the temperature will be maximum between the mid latitudes and the cold polar area in summers or winters. This contrast will be maximum in winters. However, in order to form a tornado, we need some speed in the winds. And this some speed in the cold wind will be attained in summers more. But in the summers, what will happen to this point? It will reduce. So we need balance of both. So we are in need of both contrast as well as slight velocity as well. So contrast will remain in the spring or early summer. Yes, it will remain. And in the early summer, because of increased temperature, this belt will reappear. And therefore, the speed will also increase. So in the tornado, again, I will discuss this concept. Okay. So I will use this concept. Why the tornado formation is very common in early summers and in spring. This is the reason. Okay. So this is, we are done with the polar easterlies. So about the polar easterly, again, I'm making some points. See here, the polar easterlies are blowing in which area? They are flowing from polar high to subpolar low pressure belt. Their area will expand and shrink according to the moment of the pressure belts or according to the apparent movement of the sun. And the one more point that I have discussed here, their speed will increase slightly more in summers, and in winters they will become more slow. Yes, so that is about the polar easterlies. Done. So this is, we are done with the winds. Now we are coming to the next topic. See here now. Next topic is shifting of the pressure belts. Shifting of the pressure belt. All the belts were shifting except one. What was the belt? Except polar high. Please remember this for the prelims. Except polar high, rest of the belts will shift. Right? Except polar high. Now, can you tell me what climatic patterns were induced due to this shift? Yesterday I talked about two. Let us, one is 60-70 and one I talked about the Mediterranean. Do you remember? Two we discussed yesterday. Yes or no? Yes. Sometime the Mediterranean region was coming under onshore westerly, and sometime this 60-70 was coming under the onshore westerlies, right? Now please see here. Let me show you this with the help of a diagram. So this shifting of the pressure belt will induce three climatic regions primarily. One, Mediterranean. Second, 60-70, both in the hemispheres. And the third is going to be see here now. Please understand this very carefully. However, we have discussed, let me tell you this with the example. See here now. So we are considering that this is the equinox situation. What is equinox? Where the sun will remain over exactly equator. Yes or no? This is equinox. So you can see this is 21st March or the 23rd of September. Now in this condition, we are assuming that the over the equator the sun is, and therefore 0 to 5 you can see, and 0 to 5 both side we have the equatorial low pressure belt. Do you remember that? Yes. Now here HP, if you see yes, see here the HP belt, can you see this is in the 30-35, so this is 30 and 35, and then we have, let's say this is 60. I am assuming one more region, that is 70. Okay, now see here from 30 the winds, these are trade winds. I am marking only westerly. See here, these are westerlies. Yes or no? Yes. Now can you see here the area, which area you will focus on? This area, 30 to 40, this area. In this area, if I mark here, can you see it is not under the westerlies? Yes or no? Yes, it is not under the westerlies. Now what happens is, if the belt will shift downward, let's say the belt of STHP has shifted downward. Now it is in 25 to 30. Now can you see some more additional winds will come here? Yes or no? Yes, and this area, which is this area, 30 to 40, now it is receiving what? It is receiving now westerlies. Can you see that? Yes. And now in the same way, can you understand when the belts are shifting downward, what will happen to the polar region? Is it going to expand? Just now we have learned the polar region, that is in which the polar easterlies were blowing, is it going to expand? Yes, because the belts are shifting, and therefore what will happen from here, the polar easterlies will reach in this zone. What is this zone? This is 60 to 70 I'm talking about. Are you able to understand that? Yes. So now consider two situations. The one situation, that is Mediterranean 30 to 40. In this region, it is receiving what? It is receiving westerlies. And therefore, which westerlies? They are onshore westerlies. We discussed that yesterday. Okay. And this region here, 60 to 70, it is under cold polar easterlies. Okay. Now consider the reverse situation. Here, I'm coming back to equinox, and then we are coming to the summer. This is summer solstice. What would be the sun's position? It is in northern hemisphere. In the northern hemisphere, if the sun is where the belts will shift up and down. Up, the up shifting means, see here, this is 30, 35. Now it will come under what? 35, 40. Can you understand now? Yes. Now see here, the winds, if you will see the westerlies. Now please observe the westerlies now. Are they reaching in this 40? Answer is no. They are rather starting from here. Yes, now see here, they will cross this area. and they will now enter into which region? They will enter into 70 also. So now this region, if I talk about 60 to 70, it comes under what? Onshore westerlies. And therefore, will it receive precipitation? Yes, this is going to receive the precipitation now. And what about this area? Now just see the Mediterranean region. Please focus here. Somebody has asked how it is going to receive the offshore trade wind. See here. Some portion of the Mediterranean type of region is under directly which belt? This is nothing but Mediterranean, na? So this is under directly ST, HP. And in fact, some portion from here, if the winds are starting, this western parts will receive which kind of trade winds? Offshore trade wind. So can you see from 30 to 35, this region is coming under offshore also? Yes or no? Yes? Any difficulty? Let me know. Yes, we have discussed that yesterday only. Yes. So because of the shifting of the pressure belt, this is going to be very important for your mains also. In the mains, if the question is formed, I am just giving you the areas. If you are not coming here, the preparation for the mains or all, then focus on this area as well. What is the significance of the shifting of the pressure belt? How it is important for the various patterns, climatic patterns. This is 2 patterns we have understood, right? So now I am going back to our diagram. Is there any difficulty? Let me know. Is this clear? Yes? Now come here. And now we are going to write something. See here now. See here now. So, with shifting of pressure belt, 3 type of climatic patterns will be induced globally. Number 1 is going to be, I'm writing here, 60 to 70, both in north and south. Okay, north and south. In the summers, this area, let's say I'm talking about by default, which hemisphere? Northern hemisphere. If the summers were there in the northern hemisphere, tell me which winds were there? This side, left side. What were the winds there in 60, 70? Westerlies. So this comes under onshore westerlies. And it may receive what? Because it is onshore, so it will receive, we will use the word here, precipitation, because it is higher latitude. Most of the time it will be in the form of what? Snowfall. Okay. And in winters, what will happen? In winters, it will come under what one? Cold polar easterlies. So sometime the wind's direction in this area, if you will see, the direction of the wind is like this one in the summers. And in the winters, in the same area, the direction of the winds changes in this way. Yes, so that is how the complete 180-degree reversal of the wind will be visible in this area. Are you able to understand? Yes, number 1. Number 2, second area. Second area now. What is the second area? Second area we already have discussed, Mediterranean type of climate. Mediterranean. In the Mediterranean, see here, in the summers, it was coming under what? In the summers, it was coming under ST, HP belt plus offshore trade winds. Trade winds. In which season? Summer. And therefore, it becomes very dry summer for this region. Yesterday, we talked about that. Therefore, I'm writing in very short. In the winters, what is going to happen? In winters, it comes under, this time, under onshore westerlies. Onshore westerlies. And therefore, it is going to receive the rainfall, winter rainfall. Okay, so that is Mediterranean type of climate. And the third climatic pattern which is going to be induced, it is going to be which one? Indian monsoon. That is the third one. Indian monsoon. In short, I will tell you here because you are going to learn this in great detail. So Indian monsoon, now see here. See here. For example, this is here. If we talk about India, this is, let's say, Himalayas. Now tell me, let's say this is Himalaya. Now tell me, if it is summer, right? The sun's position, I am assuming sun is here. It is, I am talking about summers. Now what happens is during this summers, you are aware about that, the ITCZ will start shifting. What is ITCZ? Do you remember? It is the intertropical convergence zone. So ITCZ, and this will shift continuously towards the north. Why it is shifting towards the north? Can you tell me? Because the land is becoming excessively hot and warmer. Therefore, ITCZ, nothing but a pressure belt, will shift towards the north. Now see here, in this area, when it shifts and it comes over exactly over the Ganga plains, right? Here it will come. This is ITCZ. ITCZ is known for two things that you will remember. Number one, ITCZ means what? It will attract from both the side which winds? That is, trade winds will come from both the sides, right? So this is known for the attraction of trade winds and then their convergence. Okay, therefore its name is intertropical convergence zone. The second thing that you will remember, it is the zone which is known for what? Extreme low pressure. So this is going to be extreme low pressure region. Okay, so this region is going to be very low in terms of pressure. Now see here, one more word we often use. This is also is known as, in India, this is also known as monsoon trough. What is trough? It is nothing but, what is trough? It is when the low pressure cells are elongated low pressure. It means this kind of low pressure cell, if it is there, we will use this word trough for that. Okay, this kind of low pressure cell, which is elongated one, we usually call this as trough. And because it is associated with Indian monsoon, so we often call this as monsoonal trough. So tell me, if the ITCZ had shifted here, so if I talk about the equator, this is geographical equator. From here, now see here, ITCZ means it is going to attract the winds from both the hemisphere. Yes or no? Yes. Now from southern hemisphere, see here, the trade winds will come and they will cross equator. Once they are crossing the equator, they are entering in which hemisphere? Northern. And therefore Coriolis force will deflect them in which side? Rightward. So they will enter in this way. So what is the southwest monsoon? Nothing but which is southern hemispheric modified trade winds. Modified trade winds. Okay, so focus on this one. See here how it is entering the monsoon, how it is entering to the region. In this way it is going to enter, and finally in the month of, let's say, June and July, when the belt, that is ITCZ, is here, it is the monsoon will enter from the Kerala onwards, right? So this is the direction of the winds that you will see in case of which season in India? That is summer. And this monsoon is known as southwest monsoon, which will be bifurcated in two branches, Arabian and Bay of Bengal, this side. So this is, can I say, because of the shift of the ITCZ, this was possible? Yes or no? Yes. And what is ITCZ? Pressure belt. So because of the pressure belt, India received the southwest monsoonal rainfall. Number one. Number two, now tell me what will happen in the winters. In the India I'm talking about, what will happen in the winters? The same belt will withdraw. Yes or no? Yes. Why? Because sun is in which hemisphere now? The sun is going in the southern hemisphere. So ITCZ, I'm considering it is withdrawing, and finally it reached here. Okay. Sorry. See here, this is, I'm considering, let's say this is October. In this area now, you will see the entire this India comes under the cold winds which are drier, and they are known as northeast trade winds. Yes. However, while passing over Bay of Bengal, they will pick the moisture and then they will become slightly moisture loaded. So now when they are loaded with the moisture, they will arrive in this area. What is this coast? That is the Coromandel coast of Tamil Nadu. Right, this is Coromandel coast of Tamil Nadu, and here, because they are becoming onshore here, yes or no, they turned onshore while passing of Bay of Bengal, and therefore they will bring the rainfall in this area. So this is the region which receives the rainfall from which winds? From this northeast trade winds. Otherwise they are drier in rest of the part. Can I say this rainfall was also possible because of shifting of belts? Yes or no? Yes. So this is how the shifting of belts is creating the different kind of weather patterns or the climatic patterns in India, especially southwest monsoon, and this is known as winter monsoon, or we can also say northeast trade winds monsoon. So this is the northeast trade winds are blowing now, and the direction is outside from India. Earlier this was inside India. Reversal of the winds, that is the literal definition of the monsoon. Yes. So this is, we are done with the shifting of the pressure belt and what kind of climatic patterns can be created. Is this clear to everyone? Yes or no? Yes. Now moving ahead, we have learned pressure belts. We have learned various factors which can determine the pressure. We have learned the various factors which can impact the winds. For example, PG, Coriolis force, frictional forces, gravity, centrifugal force, everything we have covered. We have seen the belts as well as we have seen the this one, that is winds and all. Okay. Now see here, one diagram that I made yesterday. See here now. This is equator and half side I'm making now equator. This is, let's say, STHP. Here it was SPLP and here it is polar high. Now we have learned on the surface what would be the wind from STHP. This is nothing but your trade wind. They will converge here. Yes, while converging they will become colder after reaching to certain height. Now see here the diagram. I am again just making the same diagram. Just showing you with this colors that some areas will have the cold air and some of the areas will have warmer air. Okay. Now see here, these three bells we already have discussed. Now see here, this region, that is 5 to 5. What was the name I gave to this region? Do you remember? This is doldrum. What was doldrum famous for? It is a calm region. It is also known for absence of watch winds, especially surfacial winds are absent. This is known for very weak type of wind circulation. Okay, so that is doldrum, also known as this area ITCZ. Now see here, this area, that is somewhat we are talking about in between 20-30 if this belt is, or in between 30-35. So this area also presents the same kind of conditions. Which conditions? The calm conditions which are prevailing here. Why it is so? Because in that area the winds are sinking from here. Rest of the area in the middle remains free from any kind of movement. And this latitudes here, they are known as horse latitude. Do you know why? Because of the calm region, the ships, when they were navigating through the waters in this region, especially in the ancient time, they were loaded with the horse trade, right? And therefore they felt this difficulty and they had no other option but to throw some horses away in order to lighten their weight. So this is, therefore they are known as horse latitudes. Okay. Now see here, this is known as Hadley cell. This is known as Ferrel cell, and this is known as polar cell. It is given in your handout. I am not going to cover this one. I am just giving you hint. Okay. Now see here. See here. On the surface we have trade wind, which is going from STHP to the equatorial area. Here it is becoming warmer, lighter, and it is converging. So this is going up. Then again, after becoming cold and denser, and here it is blocked partially by the Earth's axial rotation or the jet stream. Then this is nothing but it is sinking. So what is the reason of the sinking? It is, you will say, because of the Earth's rotation. What is the exact reason? Yes, Earth's rotation creates Coriolis force, and Coriolis force creates nothing but what? The jets. And therefore what happens is these jets are blocking them and they are not allowing them to go in this manner, right? So now see here, it is sinking down here. Now if you see, earlier it was considered, please see here carefully, earlier it was considered that there is only this kind of circulation from pole, because it is high pressure, from high to equatorial low, and from here it is in the upper atmosphere. This kind of circulation is there in a one cell. Later it was established this is not the form. We rather have the three cells. This is the three cells. Okay. In one cell you can see here trade winds, convergence, then this winds in the upper atmosphere, they are known as anti-trade winds, because their direction is exactly opposite, and then they are sinking here. Then see here, westerlies, they are converging, then anti-westerlies in this upper atmosphere, then this is sinking. In the same way, the cold polar easterlies, and then converging, means because of the front formation, then they are reaching here, this is anti-easterlies, and then they are again sinking. This entire thing is known as, that we have discussed, three cellular model of the circulation. Now see here, see here on this atlas, see here what I am talking about. This is the equator. See here, from equator, if I am picking any of the, let's say meridian, any of the meridian, this is the meridian. From one equator, if I am going to 30-35, what is this cell here? It is Hadley cell. The next area, Ferrel cell. The next area, polar cell. In the same way, then Hadley, Ferrel, and polar. This is on each meridian. Therefore, can I say in both the side there are three cells? Yes or no? Yes. If I talk about this one now, see here near the equator, what is the cell here? Hadley. What about here? Here, Hadley, Hadley, Hadley. So in terms of latitude, there is only one cell if you will talk about. But in terms of meridian, there are how many cells? Three cells. This type of circulation is known as meridian circulation. Why meridian circulation? Because we are talking about this meridian wise. Okay. So on each meridian, there will be three cells, no matter which meridian we are talking about. One would be Hadley, second would be Ferrel, third would be polar. So this is your model. I believe it is given in your handout. Yes, it's easy. Nothing is there. Only this thing that I have explained, that is there. Okay. So this is also known as meridional circulation. Circulation or three cell model. Meridional circulation or three cell model of the circulation. That is, you will do on your own. There is nothing much important from this area which is complex and need to be explained well. Okay? So that is very simple. Now we are done with the winds. That is, if you know which area we are talking about. In the winds, we have talked about which winds? The planetary winds. We are finished with this planetary winds, which were divided into trade wind, westerlies, and polar easterlies. That is, we are done with them. Now we are coming to the second type of wind. Now I am giving you the option which you want to learn first, whether you want to go into the local winds first and then we will discuss the jet stream, or first you want to understand jet streams. Jet streams, okay. So just give the heading jet streams. Okay, very important area this is, especially for this year. Okay, jet streams. Jet streams and western disturbances. So first we will talk about jet stream, right? So what is the origin? There are certain questions which I'm putting in here. Number one, origin. Why they do originate? Number one. Number two, how many jets are there, permanent jets? Huh? In both the hemisphere, how many permanent jets are there? 4. Yes, 4. 4. Why not more? Why not more? This is my second question. And then over equator, why they are absent? Over equator, they do not exist. And the last is, in both hemispheres, they are moving west to east. Why? These are certain questions, right? Now we will understand one by one these questions and we'll try to answer. In this jets, we will try to understand some of the very important features. First, we will learn their origin. Then we'll talk about characteristics. Origin. Then we'll talk about their characteristics. And then we'll talk about the Rossby waves. And finally, we'll talk about significance. and then we will relate jet streams and western disturbances. So this is going to be our area of discussion, and then we will see some of the current events. Current events. So this is going to be our discussion focused on. Done. So first is origin we are going to understand. Can you tell me why the jet streams are there? Why they do originate? Now we just have seen one diagram. If you see this one, see here now. See here. We just now have seen one diagram. Where is that? Okay, fine. So origin first. Now tell me why they do originate. Yes, anyone? Difference in temperature. Which temperature? Where? Upper atmosphere. Okay. This is equator. Here it is STHP. This is, I'm talking about SPLP. This is again here also STHP. This is SPLP. I'm just making the same diagram on the surface. See here, on the surface we have which winds here? Trade winds, right? So this is trade winds, right? This is trade winds on the surface. Now when this after surface, they will go up. Yes or no? They will go up. They will go up. How much they can go up? 16 to 18. Now after reaching to certain height, they will become cold, heavier and denser. Therefore what happens is they will start sinking. So they are sinking down here. Yes. While they are sinking, they will become warmer. Yes or no? Yes. They after sinking down here, creating high pressure. So this is STHP, and from here on the surface again they are going to where? Towards the equatorial low pressure belt. So this is the cell I'm making. You can make this cell with me. So this is also nothing but the maximum height up to which the upliftment is possible. What is this maximum height? It is nothing but our tropopause. Yes. Now tell me, see here now. Now tell me, if you are done with the diagram, see here now. Now see here. Focus here. Okay? आप बाद में बना लेना. See here now. So we have just created Earth. That is, I am showing you the vertical movement of the air also, and here on the surface also I have shown you. Let's say on the surface, what are the winds here on the surface? Westerlies. They are westerly, and here we have the cold polar air. Now see here, if I talk about the temperature in the upper atmosphere, here, what was the temperature if you remember troposphere? Minus 65 to minus 70. Yes, so I am considering, let's say the temperature is minus 70 degrees C, or 65 also you can take. Here, same minus 70 degrees C. What was the temperature here if you remember? Minus 45 degrees C. What is the temperature here? Minus 45 degree C. Now if I talk about why these temperatures are there, because of maximum upliftment height of the atmosphere, because of the height of atmosphere, the temperature. Can I assume this as minus 50 somewhere or minus 55? Yes or no? Maybe it would be, because it is at somewhat higher height from this area, so temperature will be further lesser. In this area also I am assuming the temperature is, let's say, minus 55 degrees C. Now compare, see here. Now if we compare, here the temperature is 70, here the temperature is minus 55. Which is more? minus 55 is slightly higher. Yes. Now, if this temperature is slightly higher, what would be the pressure condition here in comparison to this one? Comparatively low pressure, yes or no? So if I compare this two point, I found high is here, low is here. The same would be here as well. High is here and low is in this area. Yes or no? Yes. Again, I'm repeating. See here, temperature. This is, if you go by the temperature, see here now. This is 0 degree. You are going towards coldness. The coldness is increasing. This is minus 55. This is minus 45. And this is minus 70. Now tell me which is coldest. Minus 70. This is coldest. The air is coldest means slightly higher pressure. This is slightly warmer, slightly lower pressure. Now compare this two. That is minus 55 and minus 45. Minus 55, it is colder compared to this one. Therefore, it will create slightly higher pressure here in comparison to the low pressure in this area. Is this clear? Yes or no? Yes, everyone? Yes. Now see here in the same way. This will have high and this will have the low pressure here. Now in the upper atmosphere, see here. Because of the temperature gradient on the surface, see here, because of the temperature gradient from pole to equator. Can you see that? Because of this temperature gradient, where the polar area is colder and the equatorial area is warmer, because of this temperature gradient, the equator is pushing the winds above and the colder air is sinking here from the height of 6 to 8. Because of this temperature gradient, this height of the troposphere will vary. Yes or no? Why the maximum is the height of troposphere here? Because of a strong convection. Why there is strong convection? Because of the temperature is very high. Yes or no? Yes. Can I say this temperature gradient on the surface is the reason behind the upliftment here? Yes or no? Yes. In this upliftment case here, the temperatures are different here. That is also establishing the temperature gradient in the upper atmosphere. Yes or no? Which is further causing the pressure gradient. Hello? Because of the temperature gradient, we have the difference in pressure also. Now see here, from where to where wind should go? From high to low. So this is from high to low when wind is trying to start. What is the height at which we are right now? This is here we are. See here, exactly we are here. I'm talking about this is high. Okay, here it is high. Just I'm showing you outside the diagram. Now what happens is from here, the wind starts to go in this direction towards the low, this one. Now because of very, very powerful Coriolis force, which is found beyond the 1 kilometer height. Do you remember geostrophic winds? Yes. Now therefore what happens is in the northern hemisphere, where they will be deflected? They will be deflected in complete right. This would be the deflection. The moment it starts, it will be deflected to the right. समझ में आया? And therefore, where is this cell? This jet is passing from here. This is the jet. Please do not consider that jet is coming down. No, I am just showing you how it is starting in the upper atmosphere. समझ में आ रहा है 3D में? Yes, I will show you. Now tell me, what will happen here? The wind should have established here. It should have gone from high to low, but the moment it starts, it will be deflected in the right. So here it is passing from this area. In the same way, see here, high to low should have gone in this way, but the moment it starts, it will be deflected in left or right? Left. So left of wind is this one. Can you understand that? And here we have one more jet. And here also similar thing happens. And this is how the 4 jets are there. समझ में आया? Yes or no? Can I say therefore the jet streams owe their origin to the temperature gradient that exists from the pole to equator? Yes or no? Yes. And therefore in the upper atmosphere we have the temperature gradient. Yes or no? Yes. So see here, can you now tell me one question? So first I'm writing here origin. Origin. That is because of temperature gradient existing between equator to pole. So main reason is the gradient of temperature which exists between the equator to pole. Now tell me when this gradient will be maximum, winters or summers? It is going to be maximum or the steepest, it would be in the winters. This gradient is going to be steep. In which month? In winters. And therefore, can you tell me what would happen to the speed of the jet? It will increase or it will decrease? It will increase. So speed is going to be maximum. Of jets become maximum therefore in winters. Tell me till here, anybody has any doubt? Puch lo abhi. Yes? Anyone? Fine, everybody? Anybody has doubt, I can explain. Okay? After the class, maybe I will leave. Okay? So you have the opportunity to ask right now. Fine, everybody? Yes? Tomorrow. Tomorrow will be last class. Okay? Yes. I am not that capable कि सारी climatology आज उड़ा दूँ, oceanography भी आज उड़ा दूँ, है ना? So today we will probably finish climatology. If not, then in next 1 hour, means in the next class, and oceanography hardly will take 2.5 hours maximum. Okay. Done up to here? Yes. Now see here, the questions that I have put in front of you just now. See here. So one is origin. We have understood what is the origin of the jet stream. Now tell me why there are only 4 permanent jets. Why not more? Can you answer now? Because of what? Because of why there are only 4? Why not there is one more jet here? Can you tell me why there is no jet? Because it is, we do not have any gradient. This is both 70-70. We do not have any pressure gradient over here. Yes, so there is no jet. So we have resolved the another question also. So why there are only 4 jet? Can you understand? Why not there is on equator? Because there is no temperature and pressure gradient over the equator. Yes or no? Yes, simple. Now tell me why in both the hemispheres they were moving from west to east. Why? Because can you understand, even if it was starting from here, even if it was deflected to the left, it became from west to east. It became from west to east. This also becoming west to east. This also is becoming west to east. So it is because of the Coriolis force. It is, they are deflected in which direction? West to east direction in both the hemispheres. No matter which hemisphere we are talking about, Coriolis force is deflecting them from west to east. Then now we will talk about their characteristics one by one. Yes. Because of we do not have any gradient, na? What is the origin? Why they were originated in between this 2 cell? Coriolis force be 0 hai. Yes. But the main reason is why they are originated? Gradient of temperature. We do not have the temperature gradient. So there will be no wind. Coriolis force to baad mein kaam karega na. We do not have the winds at all. Okay? So that is the main reason. Now see here. Characteristics. Now see here. One by one. They are upper atmospheric air. Yes or no? Upper atmospheric air. Second, can you tell me the height? See here. See here. See here. What is the height here? 6 to 8. Yes or no? This is above 6 to 8. Sorry, above 6. Can I consider this as above 6? This cell, that is polar cell, average 6, maximum 8. This is average if I consider, this is more than that. Yes or no? If I consider this middle, I am considering that would be probably 13. Yes or no? Because this is 16, na? So I am considering this is 6, this is 12, this is 16 on an average. So can I say they will be found in between the area of 7.5 to 14 kilometer away from the surface? Yes or no? Yes. Hello? Next, one by one. Number 1, they are upper atmospheric. Which winds? Westerlies. Westerlies. And type of which winds? They are considered as the type of geostrophic winds. Yes, number 1. Number 2, height. At which height they blow? At the height of 7.5 kilometer to, they can be found 14 or 14.5 kilometer Okay, 14.5 kilometer. Velocity varies in summers. Tell me, what will be the velocity in summers? It will be reduced, and in winters it will increase. Why? Due to a steep gradient of pressure, and this maximum can reach more than 480 kilometer per hour as well. Okay. And in the summer, speed will reduce exactly somewhere around half. Okay, 480 to 240. Okay, this will be in the winters. It will be somewhat around in the summers 240. Right. Next now, can I say they are circumpolar winds as well? Yes or no? They are circumpolar winds. What do you understand by circumpolar winds? It means they are rotating around the pole. So they are rotating around the pole. This is pole. So they are rotating around the pole, west to east. This is equator on the surface. Okay. And I am talking about upper atmosphere. This is pole. They are circumpolar winds. Okay. Let me show you now in the diagram how it looks like. Okay. Done up to here? Yes. Now see here. See here now. Can you see this diagram here? In this diagram, what you can see is from here, the winds, if they are uplifted from the equator, now say here, they should have gone in this direction, but it is from here, the winds are passing very fast. Can you understand this? Can you imagine this diagram? How the winds are being crossed by the jet. Why? Because jets are moving pole to pole, around the pole. So what is this jet? If I show you, this jet is, see here, this jet is going to be moving in this way, entirely around the pole. This jet is moving around this way. Yes? Hello? Are you able to imagine? Or I will show you different diagram. See here. Yes, this one. See here. Now I am not talking about surface. I am talking about upper atmosphere. Can you see in the upper atmosphere? See here. On the surface, you have the trade winds. Okay. When they are rising, they are going up, they are sinking here. And in between, there is a fast moving jet which is passing. And this jet is not even allowing them to go and cross this side. Hello? Yes or no? Yes. Are you able to imagine this one? Yes. Now see here. In the jets, let's say we have discussed the basic points. Now some more important points for the prelims. Before going into the significance, one more point. See here now. Now, this is known as the index cycle. Index cycle of jets. Now, what is this? In the rare of the rare case, if it is asked, so what is this? Now, see here. Now tell me, is this the moment in which the jet should move? Jets will move straight or they will meander? They will meander. So they will never move in a straight direction. One more point you can put in here. They will never move straight, rather they meander. They meander. Now please understand this one. See here, the 4 diagrams I'm making here. This is the straight. Here it is meandering slowly. And in this case, it is meandering more. And in the 4th case, see here now. In the 4th case, see here now. It is meandering furthermore. Yes. So see here now. Please understand this carefully. When it is meandering, see here, when it is meandering, it can also trap the winds. For example, this is the winds, they are trapped now. For example, in this loop in the upper atmosphere. right? When it was moving, it was meandering. Some of the air may be trapped here, and some of the air may also be trapped in this area as well, right? In this way, the air has been trapped. The air has been trapped. Now see here, in the northern hemisphere, please understand this carefully. In the northern hemisphere, you will see if the air is circulating around a center in anti-clockwise, then definitely in the center it would be low pressure, because low pressure means cyclonic situation. Cyclones are known for anti-clockwise circulation of the winds. You will understand that in the cyclone. If you are seeing the winds are rather than this, they are rotating in this manner, then what is this? Essentially, this is going to be high pressure in the center. Can you tell me with this logic? See here, if we are talking about northern hemisphere, what would be here? Low or high? This would be low. This would be high. This would be low. Okay. Now consider this one. See here, what is the index cycle? Please understand this carefully. Can you tell me? See here. For example, if I am just taking this as a jet stream, and if I am pulling this very high with tension high, okay, this is high tension. So in case of high tension, is it straight or it is meandering? It is straight. And if I am just losing this, what is happening? It is meandering. Okay. So what is this tension here? You will consider this tension is the index here. It will be known as high index. It means the winds are moving. That is nothing but your jet stream is moving very in a straight manner, high. And this is your, tell me what is the index here? The index is low and therefore jet is meandering. So for the prelims, you will remember what this means. That is index cycle of the jet. If the index cycle is high, then jet will move straight. If the index cycle is low, then jets will meander for the prelims. Number one. Number two, can you tell me when this possibility will exist, in summer or winter? Why? See here, the one, let's say the river meanders in which areas? Batao? We have learned that. In which areas? Which phase? Last phase, na? Mature and late mature, or we can say old. What was the speed of the wind? Sorry, speed of the river. Slow. When something is moving slow, it will give opportunity to meander. But if something is going very fast, what will happen? It will go straight rather. Now tell me, if it is moving straight, the index is high, what should be the season? It must be winter. So please remember, the high index will be associated with what? Winters. High and a straight path. Associated with winters. Associated with winters. Now tell me, can you tell me here the low index means the meandering jet, when they will be found? In which season? They will be in summers. They will meander more. Number one. Number two. Number two. This phenomena, that is the jets will never move in the straight manner, rather they will meander. This phenomena was discovered by Mr. Rossby. And therefore, the meandering jet streams are nothing but known as Rossby waves, right? So what is Rossby wave? See here, Rossby wave is nothing but, waves are nothing but meandering jet streams. Meandering jet streams are known as Rossby wave. If I put one statement, let me know whether I'm correct or not. If I say the Rossby waves are the waves, that is jet streams, which are considered as low index jet streams. Yes or no? Yes. In that way they can frame. So can I write here the Rossby waves are nothing but the low index, low zonal index, it is jet streams. Okay. They can also give you in this way. Now see here, they can also give you in this way. One more statement if I make, tell me. The Rossby waves are the meridional jet streams. Is it true or false? Huh? Meridional. What do you understand by meridional? See here, the two things you will remember. When they are moving parallel to the latitude, this is considered zonal, and therefore we are learning zonal index. See here, this is the zonal index. I am repeating again and again. Zonal index, if it is high, they will be straight. Yes.
And now what is zonal instead of zonal? See here, if they are moving up and down along the meridian, see here, if they are moving in this way, they are moving up and down along the meridians, nothing but your longitude. So we will call this flow as meridional flow. Can I say the meridional jet streams are nothing but your Rossby waves? Yes or no? Yes. So if I make this two statement, both of them will be true. See here, Rossby waves are the jet streams of low zonal index. Yes or no? Yes. The jet streams which are more meridional are also considered as Rossby waves. Yes or no? Yes. So they will be considered as more meridional. Meridional. They are meridional jet streams. What do you understand by meridian? Meridian means they are going up and down. Okay. Done. So can I say one more point? The characteristics, if we are learning, can I say we have learned not only that they will move in the meandering manner, but also now we have learned one more thing. They are also associated with creating high and low pressure in the upper atmosphere. Yes or no? Yes or no? Yes, with high and low pressure formation in upper atmosphere. They will be associated with high and low pressure formation in the upper atmosphere. See here, this point I will use when I will discuss temperate cyclone. I will make one statement there. Okay? The statement right now, if I make, because you already are aware about the geography, I believe. Yes, na? I can ask some of the questions even if they are not being discussed. One question, if I ask you, temperate cyclones are closely associated with the jets. Yes. Second statement, the jet stream in the upper atmosphere will be directly above the temperate cyclones originating on the Earth's surface. What I'm saying is, this is, see here, this is the Earth's surface. If I'm saying this is the jet in the upper atmosphere, directly below this jet, you will have the temperate cyclone. Is it true? Directly below? Yes? Okay. Third, for the temperate cyclones to originate well, we need low zonal index of the jet stream. Yes? Low zonal index है ये. क्या होगा उससे? It is in the upper atmosphere, na? Yes. So these three statements, I will come back in the temperate cyclone. Today only we will discuss that. Now see here. Because of the steep and the less steeper temperature gradient between the equator to pole. Okay. Yes. So there are two things that you will remember. The one, if, see here, the two things that you will remember. Now see here, please carefully remember here. With this phenomena, I want to introduce, थोड़ी देर बात करेंगे. Otherwise, you will ask so many things. Okay? After some time, I will introduce. See here. So associated with the HP and low pressure formation in the upper atmosphere, as well as, if you will see, the jets will move not only in this moment in the upper atmosphere, but also if this is the surface of the earth, they will also move up and down. See here, for example, this is the troposphere. Let's say this is the troposphere. They will move up and down in this way also. And if I consider the troposphere, sometime that will also be breached. For example, this is the troposphere. Sometime that troposphere can also be breached by the jets. See here, the jets are fast moving winds. They can go up and down and up. Not only they are, see here, not only they are meandering in the upper atmosphere like this, right, this way, but also they are meandering towards the Earth's surface and then away from the Earth's surface, towards and away. So what will happen? See here, when they are coming towards, what will happen? What they will create here? They will compress the air, or they will enhance this convection. Compress the air, so they will suppress the air which is rising from what? From the Earth's surface. Therefore, they will create which conditions here? High pressure. When they are getting uplifted from here, they will help the air which is rising from below to also get uplifted. Yes. So they will help the low pressure conditions to become powerful. Also, when they are moving up and down, they can transport not only water vapor, but also what? the pollution in the upper atmosphere crossing this troposphere. Water vapor and pollutants can also be transferred. Yes, because where the water vapor will be found otherwise? In the lower troposphere. When they are entering in the troposphere, and if they are going above, they can transport both pollutants as well as the water vapor. Okay, done up to here? Yes. Now see here some more and interesting things about the jets. Significance part now, one by one we will discuss. Done up to here, everyone? Yes. So they can induce high and low on the Earth's surface also. This is, I am talking about Earth's surface. Also they were creating high and low in upper atmosphere as well. Yes. So be careful. Next now, see here, the significance of the jet stream. Significance. हाँ, अब बताओ the third statement. That is not true now. Okay, I'll come back to that. Actually, it was true only. See here now, significance. Number one, polar night jet. First, I'm just talking about the type. Number one is polar night jet. How many type of jets are there? Let me tell you. The four are permanent. One is known as, this one is known as polar jet. The second one, in between the Hadley and the second cell, this is known as subtropical westerly jet. In the same way, STWJ and polar. These are four permanent jets. Rest of them are not permanent. So polar night jet. What is this night jet? It is not permanent. It is kind of seasonal. Now see here. If I consider this is the atmosphere here. This is the atmosphere. Okay. Equally, I'm considering everywhere it is of the same height. Now see here. Do you remember one atmospheric area when I was talking about one cloud? I said I will explain in the jet. What that cloud was? Can you tell me? Polar stratospheric cloud. Do you remember? Now see here. This is the time now to understand this cloud. Now see here. If I ask you a very simple question, if it is the winter night here on the polar region here, what was the temperature? Do you remember? -68 I mentioned, Siberia. Yes, temperature goes to -68 degrees. See, I'm considering this is -68. But when we talk about stratosphere, this is a stratosphere. See here, the tropo I have made here, this is strato. The stratosphere, known for ozone. Yes. Also, because of the stratosphere, the presence of ozone is making this slightly warmer. And also, if you will go in the upper atmosphere, what was the temperature here over the polar cell? Do you remember? -45. In the stratosphere, further the temperature was increasing or decreasing? It was increasing. Now see here, if the temperature is higher from this surface towards the upper atmosphere here, the temperature has increased. If the temperature is higher here, what would be the pressure compared to the lower, this surface? This will be low pressure. And what would be the pressure here? This will be high. Now what happens, especially in the winter nights when these temperatures are formed on the surface? This is winter nights I'm talking about. Due to excessive cooling, nocturnal cooling, what happens is the temperature has decreased so low that the stratospheric temperature creates the low pressure compared to the superficial high. And therefore, what happens is one special wind will start, that is nothing but a jet, and that jet will go from the surface to the upper atmosphere in this way. Yes? Hello? What is the situation? The situation is winter nights we are talking about. Now see here, when this jet is crossing the surface area and then reaching towards the stratosphere, it will also transport the water vapor as well as pollutants in the stratosphere. Now, do you remember that cloud which we talked about? It was nacreous cloud, also mother of pulse cloud. I said from where the water vapor will come. Now, can you understand from where the water vapor is going to be transported? It is this jet, that is polar night jet. Can you understand why the name is night? Because it is the winter nights. So this is polar night jet, which is going to transport both water vapor and pollutants, both in stratosphere. Because of the water vapor, you will find here the cloud formation. What this cloud is? This is known as PSC cloud, that is known as polar stratospheric cloud. Also known as nacreous cloud. We mentioned that in the atmosphere chapter, and here I am just talking about how it is formed. Nacreous cloud. Whereas these pollutants, when they are transported in the atmosphere, especially stratosphere, so there is ozone. What will happen to the ozone? Ozone depletion will occur. And therefore, where the ozone hole is more visible? Over the polar area. Why? Can you understand? Because of this formation of the stratospheric cloud as well as transportation of pollutant by which jet? By the polar night jet. That is one importance of the jet, right? Significance we are talking about. Yes, number one. Number one, the significance. The polar night jets are known for transporting both pollutants and water vapor in the upper atmosphere, and therefore they cause losses of ozone. This polar stratospheric cloud will also enable this depletion of the ozone layer more and more faster. ठीक है, आप देखोगे, especially there will be chloro, let's say what we will call them CLO, chlorine oxides will be formed. They will remain stable, but it is the polar stratospheric cloud which will reactivate them, and they will again go and they will hit the ozone. So it is also playing important active role in damaging this cloud is also responsible for damaging the ozone. This plays active role. Damaging ozone layer. This cloud plays very important role in damaging the ozone layer. Number one. This is the significance part now we are talking about. Second significance now. Then yes. Then now the next one is I'm going to talk about STWJ. What is STWJ? Where is its control? Fine. So the second one is STWJ. See here now. What is STWJ? Subtropical westerly jet. Now see here. Please understand carefully. STWJ, I'm talking about this one. So now see here. This is India. And we talked about Himalaya. So here we have in the Himalaya, we have the syntaxal band. Do you remember this? Yes. So this is the syntaxal band. Now see here, it is the winters I'm talking about. This is the season as winter. In the winters, what happens is this jet, it is going to shift down or this is going to shift up. Where the jets will shift in the winters, because the pressure belts are shifting, they are found in between the cell. Because of that, they will shift down, and India will come under the jet effect of the jet. Which one? STWJ. Now see here, STWJ, it will come over this Mediterranean, then Black Sea and Caspian Sea. This is Caspian and Black. Now what happens is this is coming over, and what happens is when it comes here, it will strike India in this way. While it was coming over the Mediterranean, it will pick the moisture from here, especially the cyclonic storms, right? The cyclonic storms will be brought by this jet. And now what happens is, because it is loaded with the moisture, while passing over Mediterranean, Caspian, Black Sea, Iran, Afghanistan and Pakistan, it will finally arrive in India because it is the moisture. So we need only two things for the rainfall or the precipitation to occur: warm and moist air plus its upliftment. If it is hitting the Himalayas are higher here. So what will happen? Upliftment will happen. After upliftment, bifurcation will happen. Bifurcation means the one branch will go to the north, that is this side. The second branch will go towards the south, this side. South one will bring precipitation in the form of rainfall. So you will see rainfall here because of the southern branch. Rainfall. Which rainfall it is? Winter rainfall. And this side you will see what rainfall? This is in the form of snowfall rather. Because of this two, snowfall and the rainfall, this winter rainfall, especially in the regions of Punjab, then some parts of Haryana, western UP, etc. This is very important for which crop? Rabi crop. This is going to be very, very important for Rabi crop, and therefore it is, see here, this jet is not only helpful for replenishing the glaciers in the Himalayan part, it is also securing the water security plus food security, because wheat is going to be benefited especially by this type of rainfall, winter rainfall. This winter rainfall locally is known as Mawat. So can I say this is, see here, can I say this is the STWJ which brings this cyclonic storm from the western side, and they cause rainfall and the snowfall here, therefore they are known as western disturbances. Disturbances. They are known as western disturbances. So what are western disturbances? These are the cyclonic storms originating over the Mediterranean Sea especially. They are brought with the STWJ inside India, and then they cause rainfall and snowfall in India. That is how they are important for us. So what is the role of STWJ? See here, can I write here now? Second point, that is the significance I'm writing here. So STWJ, it brings, can I say it brings western disturbances in India? Yes or no? Yes. Therefore, what happens is we receive winter rainfall and snowfall. And snowfall. Yes. Therefore, it is good for us for the water security plus food security. Food security. Yes, so that is the role STWJ is playing. Hello? Yes. Now see here, something which is currently the trend is going on. I will discuss this current affair now. See here now. So what is going on with related to this STWJ? Some of the things are happening now with the STWJ. Let me tell you. So earlier the normal trend. See here, I am going into different area now. This is again, I will come back to the significance because we have started this western disturbances. Let me talk about the western disturbances here now. So see here, the normal frequency when they were arriving, normal frequency was usually 4 to 6 such western disturbances were arriving from October and to March. Okay, this was the usual trend, normal frequency. This was the usual trend. Means they were arriving in which season? Mostly in winter. Now what is happening? The new trend. See here, new trend. The new trend is they are disappearing. They are disappearing in winters. They are disappearing in winters or their intensity is reducing. Number one. Number two, they are visiting more in summers than in summers now. They are visiting more in summers. Example, June, July and August 2025. Total 15 intense WDs. There were more than 15, but I'm talking about only intense western disturbances. They arrived in India, right? And here one example, let me give you. Disappearing in the winter. So this is February month of 2023. Okay. Now we will understand why this is happening. So this new trend and what could be the outcomes of this new trend. I have given you, I think this all it is written in your handout. Let me explain now. ठीक है, दिया हुआ है ना? Yes. Now let me explain this. यार इसको लगाओ ना बोर्ड को. Now see here. See here now. the new trend that we are going to discuss now, this new trend. So first I will talk about this one and then we'll come to this trend. Okay. The third question that I will address after this discussion, if I consider the India's monsoonal rainfall, it is becoming more and more erratic as well as it is becoming wild. Have you seen that? Why it is erratic? Because some of the areas which were not known for the rainfall, now they are receiving very high amount of rainfall. For example, the western side of the Gujarat, Punjab and the Rajasthan, they are receiving high amount of rainfall. The areas which are known for the high rainfall, now they are becoming drier. The areas like Punjab, it was flooded. The unprecedented floods were there. Yes or no? Yes. Therefore, we are saying that India's monsoon is becoming more erratic and more wilder. So we will understand that reasons as well after this discussion now. See here, let me discuss now first one. What is the first area which I'm going to discuss is why. See here now. See here. This is I'm talking about the way back 2023, right? Before 2023 winters, that is December, January, February, the western disturbances were arriving lesser in number as well as their intensity was so reduced. Therefore, it was projected that Himalayas are going to receive less snowfall and less rainfall. In the February 2023, we witnessed not even a single western disturbance. And what happens is the western disturbances bring snowfall and rainfall. And therefore, our temperatures are also moderated, especially in the month of February, March, with the help of this western disturbances. Now, because there was no western disturbance, India projected that our wheat cultivation is going to drop. Yes or no? Yes. And therefore, if you are aware, India put a blanket ban on the export of wheat in 2023. Aapko yaad hai? Yes, it was because of this reason. Now see here, what exactly happened in February 2023? Why they disappeared? Number one, that we will discuss. Second, if they were arriving, why their intensity was so diminished? That we will discuss now. To understand that one, now please understand two things. Number one, you will understand this 2023 is the year I'm talking about. 2021, 2022 and 2023. This years were known for La Nina situation. Are you aware about La Nina? This 3 times back to back La Nina is considered as triple dip La Nina. पढ़ा है आपने कहीं? Triple dip means back to back consecutive years the La Nina conditions were prevailing. Because this is the area which you will learn more with the monsoon and in Indian geography. La Nina, something I'm telling you here. In case of La Nina, only one thing which is required here, I'm telling you. In case of La Nina, the equatorial Pacific Ocean will become cooler. Okay, overall. And in case of El Nino, that will become warmer. Now see here, this region I'm showing you. What is this region? Equatorial Pacific area. In this Pacific region, because of triple La Nina dip, what will happen now? Can I say it will become tropical air because this Pacific is very large and the atmosphere is connected with this Pacific. If something is happening in the Pacific, it will impact all the globe. Why? Because Pacific is so large. Now, if the Pacific waters are colder, what will happen to the atmospheric air? Will it become colder? Yes or no? Yes. So the air, now consider, just fix in this in your mind. The air over the Pacific was cooler because of what? Because of La Nina. Now see here and consider this situation. See here. Here we have, let's say, polar air. This is polar air. The color should be this one. This is polar air. And this side we have the tropical air mass. Right? Now consider, this is the area I'm talking about, Mediterranean. In this Atlantic and Mediterranean, your cyclones are going to be originated. Cyclonic storm means kind of cyclone, a smaller form of cyclone. For this formation, we need the colder polar air and we need warmer tropical air. This is something which is required to make these areas stronger, these western disturbances stronger. We need the thermal contrast between the two maximum. समझ में आया? We need the contrast. And now see here, the polar one, consider this polar one is in its intensity same. What is happening with the tropical air? What is happening to this? Is it warmer or it is cooling slightly? It is now cooling slightly, number one. So this contrast is reducing between the two. Yes or no? Yes. Now see here, the contrast was diminished because of number one, La Nina factor. Triple La Nina, ocean of the Pacific was cooling down. Second problem which was going on here, or which is going on here, that is your Arctic is no more left with the global, so let's say the global warming is occurring not in isolation, but also your this area as well is impacted. The temperatures in the Arctic are increasing much faster, and therefore this phenomena is also known as the Arctic amplification. Are you aware about this term? Why we'll use this amplification? Because this temperature is rising very fast here due to this overall climate change and global warming. Now tell me, if the temperature is increasing here, the air is now colder or it is becoming less cooler now? Less cooler. So what happens is, because of this two side, that is, this is becoming slightly cooler, this is becoming slightly warmer, and therefore this contrast is reducing. समझ में आया? Number one. So now origin of the western disturbances lies primarily on this factor. If the contrast is weaker, what will happen to the western disturbances? They will become weaker as well. Number one, this is the factor. Second thing is here, see here. Second thing that you will understand, see here, I am removing this one. Now see here, second thing. Now we have here, see here. We have here STHP, that is, let's say here it is somewhat high pressure. Yes, this is, let's say, STHP belt. See here now. This is STHP belt, that is the high pressure cell, and somewhat around Iceland. Do you remember it was low here? Yes or no? Yes, it was low. At this time in the February 2023, also these two pressure belts were weaker. Okay, both of them were going through their negative phase of oscillation. That is, we will use the word North Atlantic Oscillations, NAO. Now, NAO was further weaker. Weaker means they too were not much stronger. Now tell me, if they are not stronger, what is going to happen with the winds? Will they have the same speed, or the speed will reduce? Speed will reduce. Second, because they were not very stronger, the air which was over this area, that was no more in that capacity to handle much of the moisture. So this two factor you will remember. Now say here, what is the first factor? Why their intensity and frequency was impacted? Because of reduced thermal contrast between these two. Second, because NAO was also going through its negative phase or the weaker phase. And therefore what happened is, both in terms of intensity as well as frequency, western disturbances were not that powerful and not were originating in the same number. So this two diagram, I think I have given you in your handout. Just see there. Two diagrams would be there. Mile? It should be there. Yes. Are they not this one? Are they mentioned? Today, have you been provided one handout? Today. मिला है आज? देखो इसमें. Do we have this diagram? और नहीं है? I think I forgot, huh? नहीं है? Okay, it's fine. If it is not there, you can make then. First understand on the board. Okay, I'll give you time. Don't worry. Now say here. Have you understood this two region? Number one, because of the triple La Nina dip, the air, that is tropical air, was cooler. And second is the Atlantic Ocean was going through its negative phase of oscillation. Number two. Now say here. Because of that, we learned the intensity and the frequency was reduced. That is fine, perfectly fine. And therefore, less snowfall, less rainfall would be there. That is completely we are understanding, sir. But what exactly happened in February 2023? Why they disappeared completely? There was no western disturbances arrived in India at all. Why? Now understand this very carefully. Let me introduce now that area. See here now. The two things you will remember regarding this jets. Now see here. If I ask you, the jets are here. Let's say this is the Hadley, let's say this is the equator. One jet is here. What is this jet? STWJ. And the second jet is here. That is your polar jet. Polar jet. Now tell me, if the pressure belts are shifting up and down, will this jets also shift? Yes or no? Yes. So now tell me, if there is summer, what will happen in the summer? The jets overall will shift in which side? In the northern side. And if it is winter, they will shift to the Yes, this is clear to everyone. Yes. Now tell me, if I am increasing temperature here, more temperature I have introduced, tell me how it will impact to meandering. Tell me. If you remember that zonal index, just zonal index को याद करिए. The zonal index was high. No, therefore I am saying go to zonal index. If the zonal index was high, they were moving straight. If the zonal index was weaker, they were moving in meandering manner. Now tell me, when they were meandering, what was the season? It was summer. Yes or no? Yes. If I am increasing the temperature there, what will happen to the meandering? Meandering will increase or decrease? It will increase. Are you able to understand that? Yes or no? Yes, meandering will increase. However, with this meandering, the jets are shifting up. Can you understand that? Yes. So two things that you will remember. In the summer, overall, they will move north, as well as they will now meander more. So now see here, in the temperature, if I am increasing, I am just making them like this. See here, even if they are shifted to the north, they are meandering more. Yes or no? Yes. Is this clear to everyone? Two things. The jets will overall shift to the north when the northern summers are there. Why? Because all the pressure belts are shifting to the north. However, in the summers, they will meander more. Hello? Yes or no? I am saying, if you see this diagram, आपका diagram खोलो, that zonal index, see there. Just open your zonal index diagram. The 4 diagrams that I made. Yes. Now see there, when they were meandering more, what was the season? That was summer. In the summer, they were meandering more. समझ में आया? That 4th diagram, please see that 4th diagram. 4th diagram. They are meandering more, na? What is the season there? You have written. It is summer. So in the summers, however, they are shifted to north, but they will meander more. This thing, if you are not clear, let me know. I will repeat n number of times. They will shift northward and they will meander more. Yes? Yes? Now come back and just see this area. See here now. So these 2 regions we have understood. See here. These 2 regions we have understood. Number 1, the negative phase of oscillation was going on. And the second is we have understood there was less contrast between the tropical layer, as well as this warming of the Arctic was reducing this area, that is the colder area as well. Now see here, even if the intensity was low, the less moisture was there, the less number of western disturbances were there. They started traveling from Mediterranean. They were coming over the India, just they reached here. Now see here what exactly happened in this area. In which month I'm talking about? February 2023. Now see here. See here now. Yes. So usually what happens is they arrive in this manner. Near the India, they will bifurcate it. They will be bifurcated by this syntaxial band of Himalaya. Now it is, I am talking about February 2023. Essentially, this was the month. This is India. This India was waiting for what? The western disturbance to arrive. The western disturbances, however, the weaker they were, but still they were arriving anyhow. This is how they were arriving. Now see here. Because of the warming of what? Because of the warming of Arctic here. See here. Because of the warming of the Arctic. Can you tell me what will be the impact on this polar jet? Because of Arctic amplification, because of change in climate, because of global warming, temperature has increased in this area much faster than other areas. Because of that, what will happen? Tell me. If the temperature is increasing, this polar jet will meander more, yes or no? Yes. Now see here, the polar jet started meandering because of this global climate change. So this is the polar jet which was meandering, and while it was meandering, it was moving very close to what? It was moving very close to STWJ. Now see here, in the same way STWJ was also meandering. So while these 2 were meandering, here the STWJ meandered in such a manner that it was captured by what? It was captured by the polar jet right from here. And they too were merged before entering into India. The Himalayas were waiting, but western disturbances were captured by the polar jet. Can you understand that? Yes. And therefore, in February 2023, they disappeared completely from the India because they were captured before they arrived in India. So here they were captured. So I'm writing here. If you want to make this diagram, you can. Otherwise, it is fine. That is the situation of February 2023. And therefore, what happened is, therefore, India did not witness not even a single Western disturbances because of this factor. India did not receive even a single Western disturbance in the February 2023. Yes? Everyone? Are you fine with this? Yes? Weak means they will have less moisture content and therefore less, yes. Therefore, what will happen? They will bring less moisture, they will cause less rainfall, they will be associated with lesser snowfall. Okay? And if I say they are absent, means they are not at all reaching towards the Himalayan region. Now, what could be the impacts because of that? Can I say the rainfall and the snowfall in the Himalayan region was responsible for reducing the temperature in this area in the February and March especially? Yes or no? Yes. And therefore, do you know what happened in the month of February? It was the hottest February month of India after 1901. India witnessed the warmest February month after more than 100 years. Yes or no? Yes. And in many of the regions of India, in the February month, heat wave warning was there. Heat wave in the month of February. Can you understand what is the role that this Western disturbances play? Yes or no? Yes. So that is how the Western disturbances are important. If you will open your page, some handout, Western disturbances, is it given in your handout? After that stream, please open that handout. All the things that I had described on the board, it is written there. Just read that and let me know if any difficulty is there. All the factors, everything that I have discussed on the board, in order to save some time, I have discussed there. What is the page number? Let me know. Kya hai page number? Is it mentioned or not? Nahi. After that stream it is, right? After that stream. Yes. In my classes of the foundation and earlier classes, when I was discussing that, it was in the context of 2023. But now I am discussing even in the 2025 also. And there I made one statement. If all the students remember that, I said they are now becoming more erratic and they are visiting now more in summers. And therefore, what will happen? They will cause very heavy rainfall. And this is 2025, which exactly we have seen. It was going through heavy rainfall. It was also contributed by their arrival in the summers. Therefore, I am discussing this February 2023. Now see here, what is the new trend that is emerging? See here, their trend must be written in your handout. What is the new trend? Is it written? What are the reasons behind responsible? Are they written? La Nina would be there, NAO would be there, Arctic amplification would be there. Are they mentioned? And the meandering of the polar jet and merging, they all must be written there. Dekho. Yes or no? This is also important for your this year mains. In the mains, it can be asked why the India was going through a lot of rainfall in this months of June, July, and August, particularly. Now, see here, what other things are happening? We have understood that. Now, what were the responsible reasons behind this reduced intensity and frequency? Number one, we have learned La Nina situation, triple dip La Nina. Second, we have learned Atlantic Ocean was going through negative phase. Third, we have learned the amplification of Arctic was also making polar jets to meander more, and therefore this STWJ was captured. Now see here, what is the new trend? One more trend. Now see here, La Nina may overall the Pacific Ocean in the equatorial region will become cold, and this Pacific will transport the heat and the cooling effect to the atmosphere. See here, Pacific is so larger that it will impact the entire this tropical air mass. This entire tropical air will be controlled in terms of its temperature, pressure, moisture with the Pacific Ocean. So is the power, so is the nature of the Pacific Ocean. It is so large, right? So therefore, it is the temperature of the Pacific will determine the weather patterns across the globe. That I made the point. Do you remember? Yes. So please remember, this is the one thing that we have discussed. So I'm coming back to our discussion. See here now. See here. So we understood the new pattern which is emerging here. What is the pattern? See here. I discussed these two patterns. See here. Why they are disappearing, we have discussed, and this intensity is reducing. Second, we have discussed. Now they are visiting. Sorry, this is visiting more in summers. Example, this one. The second trend now I am discussing. Okay. Now see here. What is happening in case of see here. This trend now I am going to discuss this trend now. See here. What is happening now? If this is, I consider here, it is the global warming is increasing. Because of the global warming, what is happening to the jets overall? Can you tell me? What will happen to the jets? Because of Arctic amplification, they will become more and more meandering. Yes or no? Yes. Now what is happening? They are becoming more and more meandering, and sometimes they can be seen in the areas of the tropics, somewhat here up to 20 degree near the equator, also in the upper atmosphere. Now see here. When they are meandering here, let's say when they are meandering here, so sometime, let's say they are meandering somewhat around 2030. Now see here, this is India, and we have this jets which were reaching maximum in the Himalayan region earlier. Now what I am saying is, because they are meandering more, so sometime they can also meander in this way. In the upper atmosphere I am talking. Okay, see here. This is India. See here. This is India here. Okay. So what I am saying is, earlier the jet was maximum reaching into Himalayan region, but now because of more meandering, they are reaching in the Gujarat and MP also. Okay, and then they are meandering above. समझ में आया? Why it is happening so? Can you tell me? Because of, can I say, Arctic amplification and overall impact of what? Global warming. Now, what is happening? Because of the global warming, their intensity and their arrival has been impacted. They are arriving now in the summers also. And if they are arriving in the summer, then what is the problem? The problem is here. See here now. If they are arriving in the summer, see here now. For example, in the summer, they are reaching towards the equatorial region. Now, if they are arriving in the summer, the true problems are there. Number one, they are interacting with southwest monsoon. Can you understand that? Yes. So now see here, India was already going through the southwest monsoon. India was already loaded with the moisture, and further this moisture has been supplied by what? It was supplied by the jets also. Now what will happen? The atmosphere is loaded with a lot of water vapor, and that will cause what? Very heavy rainfalls in India. Yes, and that we have seen. If you see here, June, 5 such intense western disturbances. July, August, therefore entire India was flooded in these 3 months. Can you understand that? Number one. So what is the problem? If they are interacting, yes. See here. If they are interacting with the monsoon, example, which monsoon? 2025, that is June, July and August. So what happened is the rainfall increased in India. Floods all over. Floods will be all over. Okay. This also happened in the past. Oh, yes. See here, this happened also in the past. If you remember Kedarnath, there was a cloud burst. Yes or no? Yes. And this cloud burst was supported by this western disturbances because of a lot of moisture was there in the Himalaya. So in the past, what happened is the Kedarnath cloud burst. 2013. What was the month? I think probably it was July or August. Yes, na? Cloud burst. So in this month, India was already going through southwest monsoon and the additional supply of moisture was provided by this western disturbances. This is the problem. Number one. Number two, now see here. Number two, see here. See here. Number two. Not only they are interacting with the southwest monsoon, but also now they are interacting with the cyclones as well. Now, if they are interacting with cyclones, now tell me what will happen to the cyclone. For example, if some smaller cyclone has been originated here, let's say this is, I am giving you the practical example. This is Asna. The cyclone name is Asna 2024 in the Bay of Bengal, very small. This was cyclonic storm, the first category of cyclone, cyclonic storm. That was category 1. Now, when it entered here in land area, what will happen to the cyclone if it is reaching towards the land? Yes, its supply of moisture will be cut, and therefore what should happen to the, it will go through the process of landfall. Yes or no? Yes. Do you know what happened in this Asna? It not only survived up to Rajasthan here, this survived up to Rajasthan. It passed anyhow, and then after Rajasthan it entered into Arabian Sea, and here it gained the strength and it converted into full-fledged severe cyclone of category 5. This was something, it is still a question for the geographers and meteorologists. How come this survived in this entire area? Two reasons were given, possible reasons. Number one, it may be because of soil moisture. The soil moisture was making this cyclonic storm to sustain. But this is plausible, I think. है ना? नहीं लग रहा ना? Convincing reason. And the second reason was given, the atmospheric moisture, which was nothing but because of what? Because of this western disturbances. समझ में आया? So that is the one. The second, now see here. Second case, this is still under the question. I am just showing you how it can be interacting with the cyclone. Number one. Number two, the actually now which has been established, there was one cyclone which emerged in 2021. That cyclone's name was Taute. Now we were expecting that it should have gone in this way, but anyhow it turned towards India. Now we were expecting the landfall in this Gujarat and Mumbai area here. But do you know what happened is it penetrated deeper up to here in the Gujarat. Why it was though so? Because of the upper atmosphere was loaded with moisture at that time, and which invited the cyclone to enter further deeper. So this is Taute cyclone with interaction of the western disturbances and supplied moisture. It entered deeper in India. So these two problems are now emerging, and that is we have also witnessed in the monsoon of 2025 as well. समझ में आया? Yes or no? Yes? Hello? I am saying the Taute cyclone, if it enters any of the cyclone, tropical cyclone, when it passes over the ocean and enters into the land area, its fuel is moisture. Now what will happen on the land? Moisture will be cut, and therefore it should go through what? Dissipation. But here it survived and it was entering deeper. Why? Because upper atmosphere was providing the moisture. ठीक है? There are so many examples of such cyclones. One is such example, Freddy 2023. I will talk about that cyclone in the cyclone topic itself. Okay. Now see here. This is now the trend that we have discussed. Now some more things I want to discuss. However, they are current related. See here. The question that I have put, that is why India's monsoon is becoming wild and erratic, because some of the areas known for dryness, they are receiving more rainfall. And some of the regions which are known for high rainfall, they are now receiving less rainfall. Therefore, it is becoming erratic as well as wild. Now see here, the three regions that you will remember. See here. See here, wild and erratic rainfall is contributed by three factors. Number one that we have discussed. What is this factor? Western disturbances are arriving in, tell me, arriving in summers. And their interaction with monsoon and tropical cyclones. This is with examples we have learned. This is one factor, number one. Okay. Number one. Number two. Now see here. This one relation which has been recently established. Please remember this. If our atmosphere is 1 degree C warmer, it will learn how to retain moisture, and this moisture will be around 7% more in the atmosphere. So what I am saying is, if our temperature is increasing by 1 degree C in the atmosphere, it will learn how to hold more moisture and it will retain 7% more water vapor. Now see here, average temperature across the globe. See here, average temperatures which have been increased. Himalayan region 1.6 degree C. Indian region, that is around close to 1.1 degree C. World average around 1 degree C. Okay? However, nowadays reports are coming 1.42 degree C. Already the temperature has been increased from the pre-industrial era. Now see here, if I go with this logic, 1 degree C temperature for sure has increased now. It means, can I say atmosphere is now more loaded with water vapor? Yes or no? Yes. So with 1 degree C rise in temperature, atmosphere holds 7% more water vapor. More water vapor. More water vapor. And if the atmosphere itself has more water vapor, what will happen to the rainfall now? The rainfalls will increase, yes or no? Yes. Therefore, the rainfalls are going to increase. Therefore, rainfall is increasing. Then, the third factor that is responsible for making this entire system very erratic, see here. हाँ ठीक है, मैं समझ गया अब इस बोर्ड को 3 फिंगर पे काम करता है, एप्पल है. See here, yes. Now see here, the third and the last reason which is responsible, this is, you will say, thermodynamic effect. What is this thermodynamic effect? Where the temperature is increasing, which is causing more dynamic effect. Where if the temperature is increasing of the atmosphere by 1 degree C, it will hold additional 7% water vapor. Okay. And the third and the last reason that is responsible for, see here. If you know this one, that is, the western parts of India are now becoming more warmer than the eastern parts. Indian Ocean in the western side is becoming warmer day by day and much faster compared to the other parts. And therefore, you may have seen cyclone intensity has now increased in the western parts, that is in the Arabian Ocean. Yes. Now see here, earlier the monsoon axis was this one. See here. What do you understand by monsoon axis? Where the low pressure region was there. This was the monsoon axis. See here, monsoon axis. What do you understand by this monsoon axis? That this area will receive much of the rainfall. See here, up to here. This areas will receive much of the rainfall, and the areas which are outside, these are the regions, they will be known for what? Comparatively less rainfall, or the dry regions they are. Yes. So this is monsoon axis, where the monsoon was more or less was there in this area. Now, because of the global climate change and the warming, what is happening? The western sides are becoming more warmer, and therefore what is happening to the monsoon axis? It is also shifting to the west side now. And because of that reason, see here, if I shift this to the west, see here, this is the new shift now. This is the shifting of the monsoon axis. These areas are becoming more warmer. Now tell me, this areas here, northeast region, which was earlier wet area, rainier area, what is going to happen in the future to this area? That is going to see dry spell. And this area, which was earlier known for dry region, it is now coming under the monsoon axis. And therefore what is happening? The areas which were earlier wet regions are going through dry spells, and the areas which were known for dry regions, and they are now receiving more rainfall. So third reason is shift, westward shift. Westward shift in monsoon axis. Overall monsoon axis. Okay. So these three reasons are associated with the climate change. So they will give you in the mains, if the question will come, sir, this is prelims classes. So in the mains, if the question will come, they will ask you how the global climate change is making India's monsoonal patterns very erratic and wild. Explain with the reasons and examples. So this is the three regions that are there. Done with this jet stream and western disturbances. I am going back again into the western disturbance, jet streams. We have discussed the western disturbances. Okay? Everyone? Fine, everyone? Huh? Sorry. Erratic means something which is annoying. क्या बोलो? Erratic means क्या बोले हिंदी में? हाँ, इरेटिक मीन्स समथिंग जो बहुत अलग सा है. इरेटिक मीन्स हाँ अनयूजुअल कह सकते हैं. यस हाँ. ठीक है. डन नाउ. हाँ जी. This is nothing but what is happening. The temperatures are rising more in the western side now. And therefore, if the temperature is shifting towards western side here, if the areas are becoming warmer, what will happen to the low pressure? These low pressures will also shift in this way. So this entire low pressure belt is shifting over India in the westward side. And therefore, what is happening? The rainfall will enter in the western side. This is earlier up to here, the rainfall were more. Now they are going in this direction. It is the shift is going on. So rainfall is also shifting from here to this way. Okay. So this is all about the western disturbances, recent emerging trends, the reasons behind the rainfall of India, why rest of the, let's say, most of the Indian parts were flooded, everything we have discussed. Coming back to the discussion, I was actually discussing the significance, if you remember. Yes, na? We were discussing significance, and from there we entered into western disturbances. We have now discussed this western disturbances. Therefore, I am again going back into the significances. See here. This is the significance we were learning. Yes, here you can see. So we were actually talking about STWJ and the significance. From here, we have learned STWJ is important for India, for water security, for food security, for the rivers, for the glaciers, for the economy, for the agriculture, everything. Yes, so that is important. Next, now, the another jet, what is the significance of the jet? 2 we have learned, rest of the jets we are learning now. Now, can I say in the modern aviation, jets can take the advantage of this? Yes or no? How the jets can take the advantage of this? They can save the fuel if they align themselves with the this jets. Let's say this is the jet. They can align themselves in this way, and therefore they will save the fuel. So modern aviation takes advantage in saving fuel. In saving fuel. हाँ तो होने दो ना. That is not कि हर 1 मीटर में meandering हो रहा है. It will be in kilometers, then this will meander. So they will know precisely. This is on the modern aviation techniques. They know precisely where this meandering patterns are there. उसके साथ align कर देते हैं. ठीक है? That is their task. Don't worry about that. Okay? Second, if we talk about one more, see here. This is here. This is India, and here this is you will learn in the Indian geography. Intentionally I am leaving this one because this requires another 1 hour discussion. In the Indian geography it will be finished. The two jets are there. One is here, that is Tibet, that is tropical easterly jet, which will start from Tibet area. It will be over India in this way. See here, over India, it will remain over India in this way throughout over the India. See here, this is the India. See here. This is India. It will start from Tibet, especially in the summers. Why? Because Tibet is the highest plateau in the world, and because of high insolation in the summer, it will become very, very hot. So air will rise from here, it will go over India, and it will go down somewhat here in the Indian Ocean. Here. Okay? So see here. I'm just telling you in brief. See here now. Let's say this is the 3D diagram I'm making. In this 2D diagram, see here. This is India. Over this Tibet, here it is the Tibet, and here it is Indian Ocean. So see here, over Tibet it will start, over India it will move, it will come down here on the Mascarene region, that is Mascarene High, and then see here, it will again go back on the surface towards India. समझ में आया? Hello? This is Tibet Plateau. See here. I think this is rapid revision. Yes? In foundation, you must have learned this one. Tibet will become very hot in the summers. Yes or no? Yes. With summers, the air will rise, warm air. When it is rising, it will reach up to 6-8 kilometer. Then in the upper atmosphere, crossing the Himalayas, they will come in this way over entire India, and then they will sink here. समझ में आया? If I make them, let's say in this way, see here, the another diagram. So this is coming over, and here it is sinking down. Okay? Now you will understand better. See here, this is Tibet, and this is Himalayas are here. Okay? Consider Himalayas are here. So what happens is, over Tibet it starts, it goes over India, and it sinks down somewhat around Mascarene. Mascarene High. Now from here, after sinking here, it will create high pressure. From this high pressure, it will go towards India. Why towards India? Because what is the season I'm talking about? It is summer. In the summer, India will have low pressure inside. Yes or no? Yes, low pressure. And India will also have the monsoonal winds. That is, which wind they will be? Southwest monsoon. Now tell me, if the TEJ is sinking down here, it is creating high pressure here. From high pressure, winds will go from high to low, and therefore what you will see, India's southwest monsoon will be supported by this TEZ. Yes, so that is also one more significant point that you will learn further deeper in Indian geography. Okay, so what is the point I'm making here? TEZ plays important role in Indian monsoon. Indian monsoon. Also, one more thing that you should remember about the TEJ. While it is moving over Indian Ocean, let's say while it is moving, if I make the 3D diagram, this is 3D diagram. Now see here, while it is moving over from here, Bay of Bengal, some of the cyclonic storms will be originated, right? This cyclonic storms, when they originate, they will be diverted inside India by this TEJ. Okay, so if the cyclones are originating, they can be pushed inside India because of this upper atmospheric TEJ. So it plays two type of role. It is not only strengthening India's monsoon, also it steers up or it directs cyclonic storms of Bay of Bengal in interiors of India. in interiors of India. So this kind of role is being played by this TEJ. Okay. Done. Then one more and the last jet that I'm going to discuss about. Yes. Hello. ऐसे क्यों बैठे हो आप लोग आज? Everything is fine. I am discussing your syllabus only. Nothing from personal side. कुछ मैं अपने घर से नहीं पढ़ा रहा हूँ. ठीक है. Therefore you are looking like that कि सर कुछ अपने घर से लाए हैं पढ़ाने के लिए जबरदस्ती. ऐसा तो नहीं है ना? This is only your syllabus I am discussing, right? Yes. The last point that is about the jets I am making. See here. Significance we are learning. How many points we have seen? Not last, some more I will make. Closely associated with which cyclones? With temperate cyclone. Which one? That is polar jet. Temperate cyclone. Very closely they are associated. Jets are associated with the temperate cyclone. We'll discuss and explain in the temperate cyclone how it is. Then one more, and they see here. If we talk about Indian Ocean again, one more jet is there in the Indian Ocean. See here. This is here, if I consider, this is Somalia, that is Africa. This is Somali coast, okay? Coast of Somali. Now what happens is in this area, in the Somali coast, the winds will come and they will hit here. And this is, I'm talking about summers only. Low pressure is there and India is going through what? India is receiving which winds? Southwest monsoonal winds. That is going on. And at the same time, Africa, Somali is now receiving some of the winds. These winds will be bifurcated. One this side and second here. The one side which is coming towards India, that will also push Indian monsoon. So this is the Somali jet. It is also a local jet, not the permanent Somali jet. Why it is local? Because it is found only in between Africa and India. In which season? In the season of summer. That's it. Okay? Somali jet also, because of its speed, strengthen Indian monsoon. It is one gas that is known as radon. Radon is radioactive gas, and it is generally found from the soil. Because of the soil, this radioactive gas will be emanating. Now in Indian Ocean, do you know in this area, it is the radon concentration was found. And it was surprising for many of the scientists. How come this radon is existing over the water body? Because it is going to be from the soil, na? It is going to come from the soil. Now it was then established that it is the winds which are coming from land to land. It is making this gas of radon also in this area. So with that, Somali jet was discovered. Okay, this is somewhat the jets are there, and this is how the Somali jet was discovered. Okay. Then can I say some more points? See here. Jet stream is also known for creating alternate high and low. Yes or no? High and low, not only in the upper atmosphere, but also in the near the Earth's surface as well. And therefore, Earth's surface as well. Therefore, it impacts a lot of climatic phenomena, or the weather and climatic patterns are impacted. Climatic patterns are therefore impacted. Yes. And one more that we have learned already, that they can transport water vapor as well as pollutants, because they can cross the troposphere as well. Yes or no? Yes, while moving up and down, they can cross the troposphere and they can transport the pollutants from the troposphere to the upper layers of the atmosphere. Yes or no? Yes, so that's it. That is the jet stream. Everything we have discussed, origin, type, the current affairs, everything we have finished with now. The last part of the wind that we are left with is, we have discussed the meridional circulation. We have discussed shifting of the pressure belt. Every point which is important from the prelims point of view, we have seen now. The last part of the wind that we are left with is local winds. So give the heading local winds now. Local winds. So what is local wind? What is the meaning of local winds? Means they are moving or flowing in a very local area, limited geographical range in some local areas, right? Whereas planetary winds, what was the meaning of planetary winds? Yes, they were moving in across the globe, right? So a small scale, number one, and they can influence the local impacts. They can influence the local weather type of conditions, right? So that is how the local winds are defined. So they are local in area wise. They are local in terms of in effects. Okay. They can be divided or classified in two ways. They can be divided in two ways. Number one, based on topography, and second, based on temperature. Based on temperature. Based on topography, they are divided into two. One is mountain and valley breeze. I think we have discussed that. Do you remember that? In the temperature inversion, also we have discussed this one, sea and land breeze. Okay. Temperature wise, they will be warmer and colder. In this one, the only thing that you will add in now, see here, from the mountain, see here, the breeze which is coming from which region, it will decide the name. Now see here, this wind which we are seeing, it is mountain breeze or valley breeze? It is mountain breeze. Okay. Now see here, this is mountain breeze, and also it is known as katabatic wind. Katabatic winds. And in the daytime, it is in the night phenomena. Do you remember temperature inversion? In the daytime, what will happen? Instead of that, valley, because the air is warmer here in the valley, so warmer air is lighter and it will be uplifted. Therefore, in the daytime, you will see the reverse in direction. Wind is coming from the the breeze is coming from the valley, and this is known as valley breeze. When it is going to be common? At the time of day. And this is known as anabatic winds. Okay. Except temperature inversion that we have discussed already. Now tell me, if any of the wind which is coming down near the surface, its temperature should increase or decrease? It should increase or decrease. Exception area chhod dijiye. Temperature inversion was the exceptional case. In the higher latitude, it was exception. Otherwise, in general, what happens is, for example, it is colder air. Let's say its temperature was -1 or -2 here. If it is coming down, what should happen? Temperature should increase. Okay? And if the warmer air is getting uplifted, what should happen? Its temperature will decrease. बस इतना ध्यान रखना है आपको. Temperature inversion is exceptional case. ठीक है? And that was occurring in the night time. Fine. Already everything is discussed. We have discussed that. Also, it is mentioned in your handout as well. Yes. Rest of the winds that I'm going to discuss now. See here. It is important area. Wind already I mentioned. They are important for your prelims. Again, I'm saying. Land and sea breeze we have discussed. Land and sea breeze. Yes. Where? Factor number 3 in your temperature. The factors affecting temperature, 9 factors were there. Factor number 3 was this one. Why they are important? Can you tell me what is the importance? Yes, in the navigation they help to the fishermen. Yes or no? Land and sea breeze. We are done with this too. Now we are going to discuss some examples under warmer and some examples under colder. So one that I am starting with is the warmer one. See here, the one by one, the warmer I am discussing now. The first one is Chinook. Chinook. This is I'm talking about the America, North America it is. right? This is the North America. Here we have Rockies. From this side, I'm considering this side. Okay, the winds are coming. The winds which are coming, they will be loaded with some moisture. Yes or no? Yes. Now see here, I'm making the Rockies now. See here. This is the Rockies. Let's say this is the Rockies. This side of the Rockies, it is nothing but the winds are coming from here. The winds, when they are coming, they are warm and moist wind. Yes or no? They will be. I'm talking about winters. Even in the winters, why the warm winds are there? Because they are coming from one, from oceanic areas. So this is Rocky. I'm talking about which slope of the Rocky, eastern or western? This is eastern. Here it is western slope. Now what happens is when the warm and moist air is uplifted, what it will go through? It will go through cooling, and finally condensation will occur, and therefore you will see the rainfall is going to happen in this area. That is nothing but it is known as windward side. Are you aware about that? The other side, what happens is, now see here, air is, instead of rising, air is coming down. Please remember, the coming down of air will become warmer. Yes or no? Yes. Please see here, when the air is uplifted, the temperature is bound to decrease. Yes or no? Yes. Why? When the air is going up in the atmosphere, its temperature will decrease. Why? 1, 2, 3, 4, 5 factors. 1. Do you remember? Away from the surface, water vapor, density is decreasing, then pressure and yes. Now see here, if any of the air which will come down near the surface, its temperature will increase or decrease? Its temperature will increase. And second, that you can see most of the moisture was used here in this side in the form of precipitation and rainfall. Therefore, the moisture also left with this wind is very low. Now, just now explain, if the air will become warmer, it will learn the ability to hold the moisture. So, if the air is becoming warmer, will it easily shed its moisture? Answer is no. Because warmer one will have more capacity to hold the moisture. And therefore, this area will not receive rainfall. Rather, the air is now becoming warmer. Now see here. This is, I'm talking about winter. And this, in the winter, this is the American plain area. This plain area is under the ice cover. That is because of the very freezing winters. Now what happens is the arrival of this warm air will make this ice or the snow to melt here. And therefore what happens is this air that is coming down from the mountain, this is nothing but our Chinook. And the arrival of Chinook is responsible for melting of snow. Therefore it is also known as snow eater. Just read there in your handout. Just read that. Already we have learned. Just read that. If there is anything, just you have to remember for the prelims, which side of the Rockies? Eastern side of the Rockies. Which season it is I'm talking about? Winter season. Where it is flowing, they will ask you in that way. Okay? Especially considering the forest fires in the California spreaded by Santa Ana. The area is becoming very important for your prelims and mains both. Okay? This is number 1. Chinook. Second now, similar to the Chinook we have in the Europe, we have Fohn. Fohn. Now see here, Foehn. See here now. Fohn. In the similar way, in the Alps we have, see here, this is Europe and here we have the Alps, let's say. We have Alps here. Yes, this is the Alps. In the winters, what happens is this land side, it will be very, very cold here. Cold temperatures will be there. And in this Alps area, the winds will come from now slightly warmer from where? From the Mediterranean side. So if I make this diagram, see here. See here. The Alps I'm talking about, this is the Alps, the same effect. Now tell me, the Mediterranean side, this side of the Alp is western, northern, southern. Which side of the Alps it is? It is which side? Southern or the northern? It is southern side of the Alps, right? So we are talking about Mediterranean. Which side? That is southern side of the Alps. This is southern side. Now from the southern side, some warmer air is coming and it is rising. The similar way, it will cause rainfall here. Precipitation rather, not rainfall, precipitation. And in the other side, when it will go down, what will happen? It will also become warmer, yes or no? Now tell me, the same effect will be created here also. The snow melting will occur. Okay. Snow melting will occur. And this wind that we are talking about, which slopes of the Alp I am talking about? This is northern slopes. In the northern slopes also, you will have the same type of wind, which is known as foehn. Same type of wind, that is foehn. Next is the third that I'm going to discuss. That is Harmattan. That is third. Harmattan, also known as Dr. Wind. This is also warmer one. Now see here. This is, see here. I'm talking about this Equatorial Guinea region and the Ghana. See here, Equatorial Guinea, coastal region. I'm talking about this area. So, in this equatorial region, both your temperature as well as the moisture, that is water vapor, are going to be very high. Because of this too, they two are very high. So what happens is, if the temperature is added by the moisture, it becomes almost unbearable. And this type of temperature are known as wet bulb temperature. Are you aware about that? One is dry temperature and the second is wet bulb temperature. What is wet bulb temperature? When we take this moisture content also in the account, this is the term. Wet bulb temperature. Yes. Yes. Now say here. Say here now. In this area, because of both temperature and moisture, they two are high, the conditions become unbearable. I am talking about equatorial low pressure area. Now here we have Sahara. In this area we have Sahara. Sahara is in which belt? ST, HV. This is high pressure. From high pressure winds will go to low pressure, yes or no? Yes. So from here in the Sahara, the dry and dusty winds will start and they will go in this area. The dry and dusty winds, when they will reach into the equatorial area, can I say they will absorb the moisture here? Yes or no? Yes. The moisture will be absorbed by such winds. They are known as Harmattan winds, and the weather conditions will become pleasant because of lack of moisture now. And this wind, therefore, which is making the conditions pleasant there, weather is pleasant now, it is known as Dr. Wind. It is treating the additional supply of moisture. Samajh mein aaya? Yes. So that is the Dr. Wind or the Harmattan. So moisture is wiped out now. Okay, that is Harmattan. One more wind I that want to discuss. If you see this one, that is Californian region. I think diagram is given in your handout. In the Californian region, Santa Ana, can you see that? The direction I think is given wrong in that. Santa Ana ki direction is not correct. Open page number some 82 and 86. America, if you will see. Give me exact your atlas for a minute. De do. Just see the Californian region. Dekha in the physical. First see in the physical. Have you seen 82, 86? Don't worry. ठीक है. 82 and 86 मिला America. Just try to locate Californian region. If you are unable, then come to next page. Just one page. Flip that one page and just come to some areas. See there. Can you see this page here? This page here. If you have third, fourth edition, page number is 84. And if you have the fifth, sixth edition, then page number would be 87 or 88. Then this one. Yes, this page. Can you see that? Page number, which edition this is? Second edition, third edition, everywhere it is page number 84. For you, it is 88, hai na? Yes, 87, 88. 88 kolo. Can you see the Californian region has this warm wind that is Santa Ana? Yes or no? Yes. So that is your Santa Ana. This Santa Ana was something. It is also similar to this wind. See here. It is Santa Ana is also similar to the rocky this side. This one. Chinook type of wind it is. It means it is coming down along the hills and it increases the temperature a lot in this California. And therefore, what happens is, now see here, the same wind. If I remove this name Chinook, it is just I'm talking about which region? Californian region. In the California, there are mountains. The winds which are coming down, they are known as their Santa Ana. This Santa Ana is also dry. Why it is dry? Because this side lack of the moisture is there, and they are in terms of temperature, they have temperature which is high. Yes. Because of this, what happens is, see here, sometime their temperature will increase so much and so on that they can result into forest fire in this area. That is in the Californian region. And in 2023, in 2024, there were fires in the Californian region. And these fires were spreaded by Santa Ana. Okay. Therefore, this Santa Ana is something which is important. It is Sierra Nevada bhi hai and other mountains are also there. Okay? So from all the mountains it is coming down. Mainly it is, yes, Sierra Nevada and other. Have you located Santa Ana? Done. Now come to, we have discussed Harmattan. Now come to the last one that I'm going to discuss is, now some more names are mentioned in your handout. Just figure out Zonda would be there. It is from where? Argentina. Yamo would be there. Yamo is in Japan. Mila, some names I have given you, and please try to remember this name. It is my request. It is important. Names can be given. For example, in 2024, there was a question in prelims. They asked this one wind, that is Levante. Just see your diagram. Can you find over Spain and France Levante? In your diagram itself, it must be mentioned. Levante nahi hai. Then come to page number, open your atlas, page number 78 and 82. 78, third, fourth edition. 82, 83 for others. This page. 82 hai na? 82, yes. Mila? 78 and 82 respectively. Now see there. Can you see the winds which are there in the Europe? Local winds, they are mentioned. Now can you figure out here Levanter? Mila Levanter? They asked this question, very simple question. They mentioned which is the Levante region, where it is located. So where it is located? It is nothing but, with this local wind name also you could have located easily. It is nothing but which region? European, Spain and France area. Yes. Now please, this page ko open rakhiye. Just keep this page open. We will now talk about direction thoda ulta seedha hai. Don't worry. I'll make that correct. I know. बोरा एंड मिस्ट्रल में कह रहे हो ना, फोइन भी उल्टा है ना, जस्ट उसको सही कर लो इन योर डायग्राम और इन मैप एटलस. फोइन को सही कर लो इन द डायरेक्शन, इन टर्म्स ऑफ डायरेक्शन. फोइन जस्ट यस यस, फोइन इज शोन रॉन्ग. ठीक है, फोन को सही कर लीजिए इन योर एटलस. यस, कैन यू सी फोन इज शोन इन रॉन्ग वे. I think Bora and Mistral also, they have shown wrong. हाँ, I know that. In Atlas it is wrong. दिखाओ इधर. Not Atlas, the handout. In your handout, phone is correct na? Yeah, phone is correct. Bora, in your handout, Bora's direction is correct, but Bora is not coming from here. थोड़ा सा इधर से है, east से. So we will correct that. Don't worry. Okay. Now see here. Harmattan we have discussed. Now come back. See here. The fourth one that I am discussing is Sirocco. Sirocco. This is Europe here. And here I am talking about Alps. See here. This is Alps. This is high pressure is prevailing here in the Mediterranean. Tell me, in the Mediterranean, temperature will be slightly higher. Yes or no? And therefore, what conditions will exist? Can I say low pressure? Yes. And then over the land also, you will have the high pressure slightly more than this Mediterranean. Now see here. The same way from the Sahara, some winds, that is dry and dusty winds, will start from here. and they will go towards Mediterranean area. While they are traveling over the Mediterranean area, now see here, because they are coming from Sahara Desert, they will have the red sand with them, red sand content, okay? And when they are moving over the Mediterranean, they will pick the moisture. And therefore, what happens is they will cause, while hitting this Alps region here, they will cause red color of rainfall here, which is known as blood rainfall. Red rainfall, which is known as blood rainfall in parts of Italy and France. Blood rainfall. Okay. So from Sahara, this dry and dusty winds, while crossing over Mediterranean, they will pick the moisture, they will cause the rainfall here because they have the red sand in them, because they are coming from Sahara, red sand is there, and they will cause this blood rainfall. So these 4 winds I am discussing from the warmer side. Rest of them, only names are more than sufficient. Okay, the names you should know. Done. And where they are flowing. The cold side now. The cold side now. Number 1, that is Europe. I am going to talk about. See here, this is Europe. Keep that page open only. European page 82 and 78. See here, 78 third, fourth edition. 82 rest of you. This is, I'm talking about winter. The high pressure would be over the land compared to Mediterranean will have low pressure. Yes or no? Winters I'm talking about. Yes or no? So in the winters, land is excessively cold. Because of this cold, let's say cold conditions prevailing here, high pressure conditions are there. Comparatively in the Mediterranean, we have the low pressure. So wind will blow from high to low in this way. And these winds, because they are coming from excessively cold area, they will be extremely cold. And do you know, here we have one valley, Rhine Valley, if you can locate that. Dekha tha humne Rhine Valley? While they will pass over this Rhine Valley, because Rhine Valley is rift valley, narrow, then while passing it, they will become very faster and they can rise up also. And therefore, what happens is the flights will not cross this area, especially in winters. Because of what? Because of this excessively cold winters will create the foggy layer in the upper atmosphere. Samajh mein aaya? While passing through this area, the flights will not pass. Why? Because vertically they will create the fog conditions and they can cause accidents. Therefore, flights will avoid this area in the winters. Okay. So this is your Mistral or Bora. I am talking about which one? This is Mistral. ठीक है? That is your Mistral. Bora अभी बात करेंगे ना? Mistral I am talking about. First I am talking about Mistral. Now see here, in the same way, from this side, see here, the high pressures are here. The same way towards the Mediterranean, see here, while they are reaching towards Mediterranean, they will cross this ocean also. What is this? Sea, not ocean, sorry. This is sea. That is known as Adriatic Sea. Can you locate that? Adriatic Sea. Where we are supposed to locate, sir? You can flip one page back from your winds. You will be able to locate Mediterranean and Adriatic. Yes? Are you able to figure out that? So what happens is these winds, while they are going towards Mediterranean, they will pass over this Adriatic Sea. They will be therefore slightly moisture loaded compared to the Mistral. The two differences are there. Otherwise, they are more or less same. The two are having the different direction. One is Mistral, second is Bora. One is coming from west, second is coming from more east. The second difference is they are very dry. They will be having some amount of moisture. That is the two differences in between. Okay? Yes or no? The last one that I'm discussing, the cold one, that is Blizzard of America. Okay? See here now. Blizzard of America. This is America. America has one problem. I am talking about physical geography, okay? They have otherwise many problems. This is Rockies. Here they have Appalachian, but they do not have any mountain or the physical barrier which runs west to east. They do not have any kind of this barrier as we do have Himalayas. है ना? Therefore, what happens is in the winters, especially when the cold air can come here, do you know in the winters the belts will shift down? Yes or no? Yes. What happened to the polar easterlies? Their area was expanding or shrinking? Their area was expanding. So what can happen? This area, when it expands, this can result into the cold air flow towards the America. Yes. This is how the America, because in the absence of this any barrier here, what happens is the cold air will be able to penetrate deeper here. And this is the extremely cold winds coming from the polar region. They are known as blizzard. In the Siberia, their name is different. Buran. Dekha aapne? Dekho. See the names. Other names are also mentioned there in your handout. Try to. Buran it is. In the Siberia, powdery. Why they are powdery? Because they have the ice. Yes. So this is we are done with the local winds. They can ask you in that way. Local winds are important because of following reason. Number one, the local winds can change the local weather and climatic patterns. Yes. Local winds can also spread forest fires. Yes. Local winds can be important for agriculture in some of the parts. Where? Especially Chinook region, yes, where the snow was melting and agriculture was possible. They can also ask you in that way that the local winds are known for moderation of temperature. Yes or no? Yes. So this way they can make some statements. Okay? So this is we are done with the chapter of winds. In the after break, that is up to 6. We will resume the class at 6 and from then we will start learning new concept. Number one, we will learn the humidity and the clouds. And then we'll talk about rainfalls, right? And then we will talk about air masses, fronts, and last, that is cyclones. Okay? Along with thunderstorms and tornadoes. Done?